Hello guys, I'm Alukosha Enoch. Welcome to my math tutorial on approximation and estimation. In today's session, I'll first work on, I'll run through a board work on approximation and estimation for a better understanding of the topic. So under the that, I'll be considering the following content: rounding, upper and lower bound, and working with rounding. Then second, I'll work on some IGCSE exam style question um, on upper and lower bound. Okay, so guys, let's just get started with the board work so to gain a better understanding of the topic first. Okay, rounding. So the content to be considering here, we have rounding, upper and lower bound, then working with rounding. So guys, let's just start introduction. So we do not always need to know the exact value of numbers. Or for example, we have 1,432 pupils at East Park Secondary School. Also, there are about 1,400 pupils at East Park Secondary School. And finally, there are about 1,500 students at East Park Secondary School. So why do we sometimes round figures rather than giving an exact value? So there are four main ways of rounding a number. We can round number to the nearest 10, to the nearest 100 and 1,000, or better still to the power of 10. So we can also round numbers to, we can have number rounded to the nearest whole number. So to a given number of decimal places and to a given number of significant figures. Okay, and the method of rounding usually depend on what kind of numbers we are dealing with and how the numbers are being used. Okay, for example, all numbers may be rounded to the nearest power of 10 or to a given number of significant figures. Okay, for example, now we have 34,871. We have to round to the nearest 100. Okay guys, just a quick one. If you have to round to the nearest 10, then the last digit here should the last digit should go to 0, that it should change to 0. For nearest 100, then should have the last digit should the two last digit return to 0. To nearest 1,000, the three last digit return to 0. To the nearest 10,000, four last digit return to 0, and so on and so forth. So if you look at this very problem, you look at the digit in the 100 position. The digit in the 100 position is 71. So 71 will go to 0, so that will be 34. Now, but the problem now here is we also look at the 10th digit, this one here, this 7 here. So if the digit is 5 or more than 5, I mean the digit in this 10th position, then we round up. That is this 7 here, we had 1 to the last digit here, so we end up with something like 34,9. Okay, then this 7 1 will now go to 0. Okay, so and that is why the final answer will be 34,900. So that is to the nearest 100. Okay, so let me just walk through this. Let's just start check go through this. Now drag the numbers. This rounded to the power of 10. Okay, so we want to see to the nearest 1,000, to the nearest 100, to the nearest tens. So to drag the number to the appropriate box. If you look at this now, this digit end with two zeros. Okay, so meaning that this is to the nearest 100. So I'll be looking at this column, nearest 100. Then I will look at the number that is closer to this, and this is 27. So this should come here because this is to the nearest 100. Okay guys, but this is could be quite tricky because when you said what about this one to be to the nearest 10, because to the nearest 10 is go this will be correct, because to the nearest 10, nearest 10 till we go to 0, and this will be very correct. So it's to the nearest 10, not to the nearest 100. So and the only thing that if you thought to be to the nearest 100, to probably are going to have the same answer, but let's see what is going on. Okay, next, this is to the nearest 10 because I have 0 end it, just 1 0 here. So and the closest number to this is this guy here. So to the nearest 10 column, this is it here. So this to the nearest 100 now, and the closest number to this one is this here. So 37. So to the nearest 100. Don't forget this is 21, so it's not going to add 1 to this. This is to the nearest 1,000 because 3 zeros, but let's take a look at it very well. So I have to the nearest 1,000. If I have 1 2 3 to the nearest 1,000, then 5 will come here, so it's correct, to the nearest 1,000. So this to the nearest thousand again, and the closest number to this is this. So if I take this one, 1, 2, 3, then this will add 1 to this will become 1. So it's correct. This to the nearest tens, and the closest number to this is this. So if this goes to 0, then it goes to add 1 to this, so that will become 2. So that is to the nearest tens. This to the nearest 100, and the closest number to this is this. To the nearest 175, we go to 100, and we add 1 to this, that's 99. So nearest 100. This to the nearest 100 also, and the closest number to this is 274 up here. And if this 2 goes to 0, then you are not going to add 1, so it's correct. So it's here. And this is to the nearest guy. So if you look at this number, there's hardly, the only number that can give us 0 here is this, because if you round this one to the nearest 1000, to the nearest 1000, 1, 2, 3, then all this should go to 0. So implication is 0. So nearest 1000, this is 0. And this is to the nearest 100, and the closest number is still here. So if this 2 goes to 0, then this will add 1 to this, make 5. So that's correct. And finally, 1, 2, 3, 4. So this should be to the nearest 10,000 if I'm correct. But if you look at this very well, it's actually to the nearest 1000, because 1, 2, 3 goes to 0. Then this will add 1 to this, that will become 10. So it is to the nearest 1000. So let's check if we are correct, guys. Check. So correct. So well done. So let's continue to the next. Round to 1 dp, and to 1 dp means that let me just work with this slide. I don't need to waste my time. So we look at the digits in the first decimal place, and the digit first decimal place is 7. Okay, so to 1 dp, so the number immediately after it is 5, and we said earlier before, if it is 5 and above, then you add 1 to this, so that will be 2.8. So that's the explanation. I don't need to waste much time with this. Okay, no, so drag the number to the appropriate box, and this 1 here. So for me to have 1 here, because this is to nearest decimal, so nearest decimal 1 dp 5, so this should be 0.5. So this is 5 to add 1 to this, so that 1.0. To 1 dp here, so this is 63. So 63, the closest one here. So to 1 dp, that is 4 here. So 7, we add 1 to this. So that is so that will be this here. So that's to 1 dp. Guys, hope that is clear. And this is you want to take this to this is 3. So this one here. So but I have how many dp? 1, 2, 3. So 1, 2, 3 here. If I end this here, this to 3 dp, so that will be 540. Okay, so that's 3 dp under this. And this is to 2 dp, 2 dp. And the last one for 1, this is the closest one, 2 dp here. So this guy will 7, we add 1 to this, that will be 99. So that is 2 dp. And this is to 1 dp 0, and this is 1 dp here. So 1 dp, that is 9. Okay, 9. So this one we add 1 here. So 1 dp, we add 1 here, that will be 150. 1 dp under this. So and this is to 1 dp 2, and this is the closest one here. So this 9, we add 1 to this, make it 0.6. Okay, so 1 dp. So this 2 dp here, 2 dp for 63. So 67 here, so it's not good to add anything to 2 dp. So that's all. And 88 seems to be to the nearest whole number, but there's nothing like that. So definitely it's going to be to the nearest to 1 dp. So 1 dp here now. So 6 1 dp. So this is, we add 1 here. That's why we have 88. 1 dp. Okay, good. So now what happened with to that? So 1 dp here. This one we add 1 to this. Okay. So 63 here. What's this? 63, guys. That's not funny, guys. Okay, 63 here. Also, this is 1 dp here. This one 1 dp. This we add 1 here. Okay, so 63.5. So 1 dp. Where is it? 2 dp. So what am I doing now? 63 1 dp. Why do I have 88 there? Why do you put 88 here? Am I the one, guys? Why am I like this? So 88. Guys, we have to the nearest whole number here. I don't know why I'm doing this. We have to the nearest whole number here. So nearest whole number is cool here. Let's take this one to the nearest number, 87. So add 1 to 0.6. So this is 2 dp here, 0.6, 2 dp. 87, 2 dp. I don't need to waste time again. I think you have a good explanation, because this will be 65, so this we add 1 to this, and this is 3dp here, and 147 3dp. And if you look at this one, 3dp 1 2 3, so this 5 you add 1 to this place, making 88. This is 1dp here, so let us waste much time. 1dp, this 5 here, so 4 will not add because it's not up to 5. This is 3dp 1 2 3, so that is 87. So let's confirm that. So 1 2 3 is not going to add 1 because it's 4 is below. This could be this is 1dp, or better still 3dp, so it's relative. So let's just take a look at the question. So 0.6, so yeah, so 3dp. So let's confirm 3dp here. 1 2 3. So this 1 2 3, this is 9, we add 1 to this makes 0 0 6. So 150 finally, 150 1 2 3, so this is nearest whole number, this 9 add it. So guys, we can check. Yippee! Okay, correct guys, well done. So let's go with the next question. Number can also be rounded to a given significant figure, so let's check that. The first significant, okay, I'm just going to, I'll not really waste much time here. Now what I want to, let me just work with the example problem. So this is the first significant figure, the first counting number. So significant figure means counting number. 0 is not a counting number, but if you have 0 in between counting numbers, so 0 in between counting number is significant, but 0 after or before counting number is not significant. Okay, so don't forget that. So and if you look at this one too, if for this, for example, now these are not significant, 1 2 3 are not significant, but this 7 is significant. So this is 1 SF, this is significant, this is 2 SF, this 0 because it's between 5 and 6 which are counted, so it's significant. This 0 is significant, but these 3 zeros are not significant, guys. So that's 4 significant there. So guys, so 1 second significant, and 9 is the third significant, and fourth significant, and so on and so forth. So guys, don't let us waste much time here, we have a lot of questions to solve. So you can just go through the video again, that's why it's a video, you can rewind and work with it. Okay, now so let's take a look at this 34.0. So to 3SF, so 34.0 to 3SF, yes, this is correct. Why do I have this? This is 1SF, 2SF, because this is 0, it's in between counting number, between 4 and 2, so it's significant. So 1 2 3 4, so this is 4SF. This one 0.07 though is closer to, if you look at this now, we have 0, so this is 2SF because all the 0 are not significant, so this 2SF, so only 78 is significant. This is 200, so 200 can go to this is the only 1 SF, so this 1 SF, that's the only significant figure. And let's confirm now, if you take this one, the one that's significant figure, because this is 5, so 5 you add 1 to this 200. So this one 1 2 3, this is 3 SF here, so 3 SF should come here, and you can confirm 1 2 3, so 5 you add 1 to this. This is 1 SF, 1 SF, why let's say 1 SF, this should be 1 SF. So what's going on there? Okay, so this answer here is 1 SF. We gave me, this is not 3 SF, this is 1 SF. So I don't know why I put 200 there. I don't want to put 200 there, guys. So this 1 SF, so 1 2 3. Okay, so these zeros are not significant because they are not counting number, so this is the first counting number here, this 1 SF. So what happened to this 200? Why did I do that, guys? Why did I do that? Because 200, this is 1 SF here, it's meant to be here, so I don't know why I did that, guys. I'm too playful. I can be super playful sometimes. So one is significant, so this we add 1 to this. So 6.4, this is 2 SF, and you can confirm. 63 is significant figure, 1 2, then 5 you add 1 to this. 34, so 34 is 2 SF, and you can confirm this 2 significant, so this 0 will not add anything. So 151 is 3 SF, so 3 SF. What am I talking about? 151. God. Yeah, it's correct, 3 SF. So why did I do that? 1 2 3, because this 0 is in between counting number, so this is the third significant figure, so 1 we add this. So now where is 200 now coming? 2 is 1 SF, and I put it here, I said 1 SF, this is 1 SF, guy. Why is Aluko super playful today? So now look at this one, this is 1 2 3, this is 3 SF. Yeah, cool, we can confirm this is not 3 SF, guy. Why am I like this? These zeros are not significant, so this 5 is significant, 7 is significant. So it's 3 SF, guys, 3 SF is correct. So 30, so 30 should go to where? So 30 should go to 1SF, because this, if you take this one as the first counting number, so so one is not going to add one, so others go to 0. So 150 should be here automatically without checking. So 15, so that is 2SF, and that's all. Let's check, guys. Check, guys, this is a video. You can just rewind and go through again and see. Well done, guys. Upper and lower bound now. So numeric, guys, you need to listen here, because most of the application we have for the IGCSE exam style question application on that lower and upper bound. So you have to listen very well. So the first thing is that we need to differentiate between numeric we have two type of numerical data. So your numerical data can be discrete. Numeric means counting number, numeric, okay? So it is not categorical, and it is not string data if you are into programming. So strings, you know, strings are like that's text. So numeric, okay? So numeric. So numeric data, we have discrete and continuous, okay? So discrete data can take certain value. Better still, let me just tell you this. Discrete data are countable data, okay? So anything you can quantify, you can count, so they are discrete. While continuous data are measurable data, so anything, any quantity you can measure, so they are numeric. But quantity that can be counted, they are discrete data, okay? So I think that's better. So for example, boot size. So for example, if you like boot size, this is sizes, okay? So what do you have sizes? Number of children in class, you can count, okay? Amount of money is countable, okay? So continuous data are measurable data. I said that earlier, so I don't need to waste time. So for example, you have weight, time, and height. So let's just move ahead. So the population of United Kingdom is 59 million to the nearest million. So in what range of value could the population be? Guys, I just need to give you this concept now, because I'll be very fast now. So let me just give you this rule. So, and I'm not going to recall this again. Now, what I want here, the concept I want you to understand is this time. So anytime you are solving problem involving upper and lower bound, the first parameter you have to go for is the error. And the formula for error is place value, place value, place value divided by 2. So guys, I'm not going to recall this formula again. Error is place value divided by 2. So you just master this. So I'll be working with this now. So for example, now this says to the nearest million. So million, the place value there is million, and that is 1 million. 1 with how many zeros? With 6 zeros. That is million, okay? So 1 with 6 zeros, that's million. So the place value for this question is 1 million. So error will be the error there will now be 500,000, because error is always place value divided by 2. Okay, so 500,000. So guys, don't forget. So now this question says, in what range of value could the population be? So the range of value, now this population, and it's a discrete data. So discrete data, I don't need to represent it as a continuous data. We represent continuous data in range, but discrete data is as a value. So in that case, let me just, as though it was a continuous data, but this is what we are going to have. So generally, what you're going to have, the estimated value will be the original value, which is 59 million. So million with 6 zeros, 1, 2, 3, 4, 5, 6. We now do plus or minus the error value. So and the error value here is 500,000. So guys, at this point, I'm going to work with my calculator now, because I will not be careful to explain this again. So now, so what range now? So we have the lower bound, that the least population we are expecting there will be 59,000 minus 500,000. So let me go to work with my calculator there. So let me just work with my calculator there. 59,000, 1, 2, 3, 59 million rather, 1, 2, 3. So 59 million minus 500,000, 500, then 1, 2, 3. So guys, I'm using my calculator here. So that gives me 1, 2, 3, 1, 2, 3, 58, 500. So 58, 500, then 0, 0. So that is 58,500,000. So this will be the least population, or we can call it lower bound, or the least population, as the expected least population. Then the upper bound now. Guys, don't forget, this is semi-discrete data. So just be careful. I'm going to do something now. So now if you add this one, I don't need to waste my time. This will just give me 59,500,000. Now if this question were to be if it's a question involving this continuous data, I'll just express it in range. So I'm going to have something like 58, 500, 1000, less or equals to, meaning that this is inclusive. Population, let me represent that one by with P. Then strictly less than. Strictly less than, that this population will not be included. So strictly less than 59. Don't mind me, I'm not I didn't manage my board very well. So guys, just pardon me for that. Now, but this is I express my answer as though it is a continuous data. So now, so the implication of this is that I don't need to write all this 9, okay, because this is not inclusive. So now let me just run through the slide because to save time. So the most this could be therefore we have 58, 500,000. So I thought you what to. Now this one is, why is this one, or like what I have here, because this is discrete and I told you that that is not inclusive. So why do we have 59,499? So why? Because I'm expected to have strictly less than, but this is inclusive. So if I want to write this one, I'm going to write this population, then this. So mean that this is inclusive and this is inclusive, but the way you normally write before, but if you want to write it as strictly less than, so that will be 59, 500, 1000. So this will now be strictly less than population, then less or equals to, this is inclusive, 58, 500. So guys, don't forget, so if you have problem if you are solving question involving discrete or continuous data, then you should know how to express it in range. This is how this is going to be like, and in range this is cool, but we don't normally use this. So this is the acceptable format. So and I will use this to represent continuous data, but this one now we are giving a point value. So this is a point value, so you don't need to put this here. So that's why you just write it strictly like this. And now, so why do we drop this one? Because 59 is strictly less than, so what number is 1 less than? So this is 1 less than. So if you take away 1 from this, then you have this, so this will be included. So that's why it's that. So guys, that's cool. So because the question will be solved in the IGCSE exam style question, probably will not have nothing to do with continuous data, or sorry, with discrete data, and also we'll be expecting we are expected to represent it as range. Okay, so that's why we go with this. We may not necessarily go with this. Okay, so that's a good one. Okay guys, let's just continue with the slide now. So and this is the explanation now, so you can see. So this inclusive, but this not inclusive. So this is a very good one. So guys, the video you can rewind, you can pause and get it. So you know, you understand when we but the only thing I just want to call your attention to now is that in a standard GCSE exam question, the examiner is not expecting us to give this type of solution. So guys, please in your exam, and I want to say this again, please and please don't express your final answer in this form. So this form is cool for us. This form is okay. So please use strictly less than is okay. So we don't want this form even though it's correct. So this form is okay. And I explain why. Okay, so this is called the lower bound and this is called the upper bound. So last year shopkeeper made a profit of this. Guys, at this point, because of our time, I'm going to discuss. I will just discuss the solution. So then I will tell you what is going on there. So let me just go ahead and tell you what is going on here. Now, so last year a shopkeeper made a profit of 43,250 to the nearest 50. Now to the nearest 50, guys, is this pounds or euro, guys? Guys, is it pounds or euro? What? Why am I like this? Okay, so is this euro or pounds? So I care little about that, guys. So it's just the unit here. Now to the nearest 50, the place value there is 50. So then what we need there is error, because we use error to calculate lower and upper bound. So 50 over 2, I explained that before. So that is the error, place value divided by 2. So that is 25. So what we now do now is to, if you add 25 to this amount, add 25 to it, or take away 25 from it. And don't forget to say that I don't really like this format of writing, so I'm going to display the last one now. So we just add 25 to this and take away 25 from it. So that's what is going on. That's why we have this answer. So to the original question, so if you have 25 to this, that would be 275. So this one not acceptable in standard exam. So just use strictly less than, less or equals to 43, then 275. Guys, this is correct, don't forget. I'm only talking about that in standard exam, so we like to use we represent like this. So and the other part are okay, so very okay. So that's the other option. Okay guys, at this point I'm going to explain better here, but before I start solving the problem, I have my calculator here, then I can write. Okay, but I think I'll just work with that. Now what I want to do now, number of people, lower bound and upper bound, to the nearest 500. So nearest 500, this place value 500, so 500 divided by 2, so 250. So I'm going to take away 250 to get lower bound, add 250 to get the upper bound. Here I'm going to take away 50, because that's 100 divided by 2, then add 50. This one take away 50, add 50. This one take away 2.5 and add 2.5. This one take away 500 and add 500. This one take away 25 and add 25. This one take away 25 and add 25. This one take away 50 and add 50. So that's how I'm going to come about my exam. But it's a discrete data. So the problem I'm going to have with this problem is that instead of adding I'm going to take away 50, okay, but this one is not going to add 50 because we don't want to do less or equal, so it's now going to add 49 instead of 50 because we want exact value. Don't forget that. So I will just click and you see the answers. So that you see now, so that's correct. And because here we take away what, take away 25. So if you take away, sorry, 250. So if you take away 250 from this, let me just use my calculator to confirm that, then I will not be careful to do that again. So you have 2 1 0 0 0 3 zeros, so minus 250. So that gives us that answer there. Do you see now? Okay, then the second one now, I'm meant to add 50 so that I can have something like strictly less than. But because this is a discrete data, this data wants equals to exact value. So instead of adding 50 now, so I'm add something 1 less than 50. So I'm going to add 49. So that is 2 1 0 0 0, okay, plus, because it's upper bound, 49. I'm meant to add 50 to get strictly less than, but to get exact value, that will be 49. I don't know whether I type for plus 49, guys. So I should have 21049 if I type this place. So that's correct. Okay, so don't mind me. What did I do there? Let me just check again. So 2 1 2 1 0 0 0 3 zeros, then plus not 49 because this is 500. 500 is 250. So 250, so 1 less than 250 is 249. 249, 1 less than 50. It's meant to be 250 for strictly less than. But if you want to have less or sorry, for strictly less than, but if you want less or equals to, then that will be 1 less than 250. So that's why we have the answer. So 21249, guys. So and I don't need to confirm that, guys. Just go ahead and let me return my calculator. So that's what is going on there. So this, because these are discrete data, so instead of for you to add 50 here, so you are going to add 49. This one, instead of 25, you add 24. This one, instead of 25, you add 24. This one, instead of 500, you have 500, that is 499. This one, instead of to add 2.5, you add 2, something like that. This one, instead of 50, are like that because you want exact value. It's a discrete data. If you have to be continuous data, then you treat it the normal way. So don't forget, please, your normal exam style question oftentimes are continuous data, and it's also allowed. You can express this as less or equals to. So because this is a board work, that's why I just have to show you this, guys. So next, so now this is continuous data. This is a very good one now. So in continuous data, I don't need to waste my time again. Now let me just make this note. Anytime you have nearest, all nearest units, the place value is 1. Let me say that again. All nearest units, the place value is 1. For the last time, all nearest units, the place value is 1. Such that error will now be all nearest units, the place value is 1. What do I mean by all nearest units? You can have the nearest centimeter, nearest kilometer, nearest meter square, nearest all nearest units, place value is 1. So don't let me say meter square, guys. So all nearest units. So whether centimeter, millimeter, or it could also be to the nearest amount of maybe nearest dollar, nearest naira, Nigeria, nearest euro, or nearest whatever, or nearest unit. Place value is 1. So now this one says the nearest meter, so place value is 1. Okay, so error will now be place value over 2. So here I'll be dealing with what? 0.5. So now you take away 0.5, then you add 0.5. So that's what we are going to do. So let me just use my arms and body work because of time, and that's what we have there. So now do you see now is as this one we write as range, so it's okay because this is strictly less than. But if you want to put equals to, then you know what is going on. That will be discrete, but we don't need that anyway. So guys, nearest now, so take away 0.5 here, you have 3.5, then add 0.5 to this, and that's what we end up with. So that's it. So we don't need to waste much time, you understand already. So guys, this is video, so you can just go ahead and do that. I will not really be careful with this one. To the nearest 5 centimeter, so you take away 2.5 and add 2.5 to get your upper bound and lower bound. So so on and so forth. This one to the nearest 0.01 centimeter, just divide this one by 2, then take it away and add it. This one place value is 0.1, so divide 0.1. This one to 1 dp, so to 1 dp means that 0.1 divided by 2, so the error will be 0.05. So take away 0.05 and add 0.05 to get your upper and lower bound. To the nearest centimeter means that to the nearest unit, so that is 1. So 1 divided by 2 is 0.5. Take away 0.5 and add 0.5. So that's all. And if you want me to see the answer now, let's just check 3.5 and 4.5. So because then let me go back to this one now. You take away what? 0.05 and add 0.05. So you see the answer. For this one now, you take away 0.005 because you have 0.01 divided by 2. So that will be 0.005. So add 0.005 and take away 0.05, then you get this answer. So guys, that's cool. So let me just go to the nearest. So working in round, can I work with this one? Let me see. Can I just start my question? Guys, I have a lot of questions to solve, but let me just take a look at this. Guys, let me just quickly give you a clue on how to solve this problem. So this is the test piece and they do not fit. Explain how this happens using upper and lower bound. Now, if you look at the first question here, the cylinder here, and one company makes piece 4 centimeter diameter to the nearest 0.5. So nearest 0.5, the error here will be 0.5 divided by 2. So in that case, you are going to take away, let me just look at this one, 0.5 divided by 2. So that is 0.25. So add 0.25 here and take away 0.25 here to 4. Add 0.25 to 4 and take away 0.25 to 4 to get to upper and lower bound. This one now, error here will be 0.1 divided by 2. So you add 0.05 to 4.1 and take away. Then you see that the upper bound and lower bound are not the same, therefore they cannot fit. So that's it. Is there anything to do here? Okay, I have a lot of questions to solve already. So to 1 dp, so to 1 dp means that 1 dp is 0.1. Guys, 1 dp is 0.1. Let me just write that one there. So 1 dp is 0.1. So your error will be 0.1 over 2. So here you are going to add and take away 0.05. So add, take away 0.05. So this one, take away and add to get your upper and lower bound. Do the same thing for this one too. Okay, so this question now says the carpet is cut into shop and can fit accurately the same size. What is the smallest size? So the smallest size now, so the smallest size I don't even need the add. So this one, take away 0.25, get your answer here. The carpet is cut into shop and can be cut accurately the same size. So that's all. So that will be the smallest size. You don't need the second one, the upper bound. If you ask you for the biggest size, then you go for the upper bound. So that's cool, guys. Okay, this one says that the carpet costs 12 per square meter. So the answer you have here, per square meter means that you have to multiply because the bedroom is a square, all right, is it? And the dimension. So you just multiply the lower bound here. Can I solve that question, guys? Let me just solve the question with you guys. Okay, don't let me to be fast. If I have a lot of questions to solve, but let me just do that. I have a lot of questions to work with. So but let's just do this. The video will be quite too long, but no problem. So to 1 dp now, 0.1 divided by 2, so that is 0.05. So I'm going to do 4.2 minus 0.05. 4.2 minus 0.05, so that gives me 4.15. So the lower bound there is 4.15 for the first that part. Then by take away 0.25 from 5.452, so 5.4 minus 0.05, so and that is 5.35. So by 5.35. So guys, hope that is clear. So take away 0.25 from here, take away 0.05 here, and since it's is more of is length times breadth to get the area, because it is a rectangular bedroom. So that's the area. So just go ahead and do that. So 5.35 times 4.15, and that is 22.2025. 22.2025. So guys, so now that is the dimension. So per square meter, this is the square meter now, so this is meter square. So if 1 meter square is 12, is this pounds or why am I like this? Why do I have problem with pounds or euro, guys? So this is euro, right? Okay, so per square meter is 12 pounds or euro, whatever it is. So just so 2.25 just be times 12, and you get your answer there. So guys, do you want me to finish up everything? Time is going, guys. This is video. So the money we have there will be 266.443. So guys, that's that. So guys, I actually have a lot of questions to work with, but let me just discuss this with you guys. So it as this one. What are we asked to do? What is the lowest and highest? So lowest and highest of suite in each possible. Explain your answer in terms upper bound and lower bound significance figure. So guys, that's that. So let's just go ahead with our question. I'm done with guys. I don't want to change. No. So let's get started with the exam style question. This is the deal for the day, guys. I don't know how many minutes I have left now, guys, but this video will be too long. I just have to be fast. So tutorial on approximation and estimation, upper and lower bound, GCSE, IGCSE, IB, PSAT, and AISL exam style question. So if you look at this question now, the length of a rectangle are given to the nearest centimeter. So initially from the board work, you know that all nearest is 1. So error is 1/2. So place value over 2, that is the error. So that is 0.5 based on that question. So because to the nearest, all nearest 0.5. So state the range of which, so this one now, the range of which length and the width must lie. So the length, which one is the length, which one is the width, guys? So it's relative. The length and the width is relative, but we know we do take the longest side to be the length of oftentimes. So the longest side we do take it to be the length. So I'll go with 4.2 as my length, guys, but it's okay. You can just take any for your length as your width. But conventionally we do take the longest side as the length. So the length here is 4.2, so I can go ahead with my answer now. So what I want here is just the range, so and it's a continuous data, don't forget. So take away 0.5 from 42, this will be 41.5. Then add 0.5 to the value, so 0.5 to 42, that is 42.5. So that's the solution to that. So I can work with the width too, the same error. So that will be 31.5, take away 0.5 from 32, then add to it. So this will be 32.5. So guys, I don't need to check it's correct, no time. So this one too, this one asks me to find the value perimeter and the area. So now if you look at this now, this plane shape is a rectangle. So the perimeter is 2 into length plus breadth. Just add all the sides, guys. Now, but the problem you likely going to run into now is length plus breadth, because you know it's length plus breadth, guys. So the length here, find the range of the value with which the perimeter and the area lies. Okay, because better, so what we are doing is that perimeter means that you just add all the sides. Maybe you like it like that. So I think it will be easier for you. Don't let me use formula to, I don't need to confuse you guys. So just add all the sides now. Okay, so I have this one here, 41. So the lower bound here now, so 4.15 the length. So we are going to have the lower bound for the length, and we're going to have the upper bound too, so it's a range. Okay, so now let me work with the lower bound first. So I want to work with the lower bound. So these are the lower bounds for the length and the width. Okay, and these are the upper bounds. Okay, so these are the upper bound. So that's a good one. So and the formula is swing to left plus right. So then you can go ahead with the lower bound first. So for the lower bound now, if you don't mind, I can still work with that. So for the lower bound now, I have 41.5 and 31.5. Okay, so because if you want to go, that's length times breadth, or you want length times width, because we are dealing with width. Don't mind me, that's lower bound, not the length times breadth. So now length times breadth here now, let me just do this so that I need to waste my time with this guy. So this is the length here, this is the width here. So 2 into length plus breadth, right? That's perimeter. So that is 2L plus 2P. Okay, 2L plus 2P, that's the perimeter. Okay, so now but what we're going to do for the lower band here and for the upper band here too. So 2 also here into L plus B, because it's a range of value. So we have the range for the perimeter for the lower bound, we have range for perimeter for the upper bound. Okay, so for the lower bound now, you work with this guy here. So I don't need to waste much time here. Let me just put it here. Let me just use this arrow to indicate I'm going to put my answer here. So now this is the length here, this is the width here. So let's just sum, then 2 times that. So that will be 2. Oh guys, so that is 2 into, so if you add this guy here, 41 plus 31, that is 72. So that will be 73. 2 into 73. So that will give me my lower bound. So the upper bound to do the same thing here now. So if you want to add this guy here, 42, this 42.5 and 32. So 42, this is 74. So that will be 75. Then 2 into 75. Guys, this video you can pause and you can look at what I'm doing and get it. Take your calculator and do that, guy. So this is my lower bound and this is my upper bound. So I can write my range now. So the range of value I'm going to have for perimeter, because I will now use P there. So my final answer for question 1 will be 73 times 2. So let me use calculator now. 73 times 2, that is 146. So 146, that will be the lower bound, guys. 146 less or equals to perimeter, because we are dealing with perimeter now, strictly less than, then the upper bound, 75 times 2. 75 times 2, 150. So now for that, so meaning that 150 will not be inclusive. So we can have 146, 147, 148, and 149. That is the range of the perimeter that is possible for this question. So also for the area, use the same method. For the area, that is 2 length times breadth. Guy, why am I saying 2? why am I like this? Area is just length times breadth, guy. Okay, so area is length times breadth. I can be quite playful, guys. So we have the length already, guys. So this time around we are working with the length. This is not length width. So this is length times breadth. So length times breadth here. So then this length times breadth here. So multiply the lower bound because we need length times breadth for the lower bound and we need length times breadth for the upper bound too. Okay, so for the lower bound now, this is lower bound, lower width and the lower length. So length times breadth multiply. Guys, this is not funny. So this is 41.5 times 31.5. So guys, not funny. So 1307. So let me just write my answer here. I don't need to waste much time. 1307. So that's the lower bound for the area. So less or equals to area, then strictly less than, then you now multiply the upper bound. Now that is 4.25 times 32.5, and that is 138.1, okay, 0.25. That's what I have there, 0.25. Okay guys, the length of is given to the nearest meter now. So this is where there is trouble. Say that the nearest centimeter, guys. So if you want to eliminate this, you can just have 138.1. So that's strictly less than. So and that's the answer. So we don't need to waste much time. Of the area it must lie between, okay, so we can now write our answer here. Perimeter lies between 146 to 150. And area lies between 1307 to 1381. Okay guys, that's the end of this question. Can I take it away? Can go away, guys. Time is going. Let me see if I can. I think I'm just going to, because of our time, guys. You can just what we're going to do now, please. Just log on to www.test.com/member or just copy this in your Google URL. Then you're going to have access to all these questions you can complete. Because of our time, I will not be able to complete all the questions. But if you look, I can just discuss. I will discuss it and give you a clue what to do. So I'm not going to solve and write everything. So I'll just discuss now. So for this one here, you have to find circumference, diameter, and area. So for area, since it is a circle, radius of a circle, so a circle now, area of a circle is pi r square. So that's what you're going to do there. This one is circumference, that is 2 pi r. That's what you're going to do there. And this radius, that is diameter, is 2r, 2 times radius. Okay, now so we are giving radius already to the nearest millimeter. So nearest millimeter means that is 1. So the lower bound here, lower bound will be 12 minus 0.5, that is 11.5. And upper bound here will be 12.5. So I'm done with that. So that's question A. This range between 11.5 and 12.5. So guys, don't forget, I'm not going to waste my time now. So now when you now come here, this diameter, you just do your lower bound and upper bound will just be 2 times this. I don't know, you just want me to do everything. Let me just put it there. 2 into 11.5. So guys, just finish up. I'm supposed to write the answer there. And this also will be 2 into 12.5. So that's what you're going to get there. This one, you have the answer of the 2 into here. So just multiply your answer here, pi. So or you can just leave it with pi. So this will be 2 into 11.5. Oh my god, why am I solving bars like that? Then times pi, which is 22/7. So this one will also be 2 into 2.5 times pi here. So for area here too, so you square this one. So 11.5 times 11.5 times pi, then 12.5 times 12.5 times pi. That's solution to that, guys. This is video, guys. This video. So you can go ahead and do that. For this one, minimal to the nearest what? To 1 SF. Let me just work with this. Guys, I need to show you something here because this first time I'll be working on significant figure. Now to 1 SF here, guys. So let's quickly take a look at error here. Now if you look at 1 SF here, the first counting number here is 1. So and the place value implication is 10. So here 2. So the place value is, so the error there is 5. So for this x, the lower bound is 15 and the upper bound is 25 for x. Then for y, the lower bound is take away 5 from this guy, 35, and the upper bound will be 45. So guys, I think we can finish up now. So they want you to do x plus y. X plus y means that you add the lower bound and the lower bound, you get your answer. But this question actually asks us for minimum value, so we have nothing to do with the upper bound, so you just add these two, you get here. Then take away these two, 25 minus 15, you get this one. Multiply these two, you get x of this one. Okay. So now when you now get here now, x divided by y, this is where there is going to be a problem. Now when you have division, we want you to make it, because we want minimum value. So for minimum value, you go for the minimum of x, which is 15, then divided by the maximum of y. Don't forget guys, divide by the maximum of y, because we want to make it very small. Because if you were to divide by the minimum of y, then it's going to be a little bit bigger than this. So that's how to do division. So for this one also, because we are looking for minimum possible value, so we'll go for minimum of y. The minimum of y is 35. Then you now divide by the maximum of x, and the maximum of x is 25. So if you want me to write this one for you, maybe you care about that. So minimum of this one will be 15 times 25. That will be the answer here, because we are looking for minimum value. So y now, don't you see that I'm wrong, guy? Why did I do this? This xx, this is not xx. So x here minimum, x minimum here is 15. So let me just do that, guy. Don't mind me, too playful. So minimum x here is 15, correct? Then go for minimum of y too, 35. So see, it's very unlike the way I treat the division. I divide by 35. So also for difference here, the list of y is 35 minus the list of x, that is 15. And this one now, the list of x 15, and then plus the list of y, that is 35. So that's solution to that question. So guys, this video, guys, you can pause, you can rewind, and say rewind. Okay, just watch and take a look at it. So for this one here, what is the possible? Okay guys, let me just work with this one, because this question here, you are not giving to the nearest to a particular estimated, no estimated value here. So you are going to figure out your estimation by yourself. So if you look at this guy here, this is how many digits? 1 2 3. So this is to 3dp. So to 3dp, that is 0 point, then all this one goes to 0 0 1 0 0. So this last digit will go to 1. So that's how to treat this number, because now this now means what? To 3dp. So to 3dp, that's 0 point. 3dp means 1000th. That is 1 over 1000, and that's what you have. So your error will now be over 2 now. So this 1 over 2. So you can now go ahead now. So if you do this 1 over 2, your error will be 0.0005. So you can finish up now. So to get your upper and lower bound, you just have 2.475 minus this. Then do you want me to do everything for you guys? I don't know. Must I do everything? This is tutorial 2.475. Am I correct? I'm just through, I'm in east already. 2.474. So 2.474 minus 0.0005. Guys, don't forget, if you do this one divided by 2, that's what you're going to get. You can confirm with your calculator. So minus gives me what? So that's the answer here. 2.4735. 2.4735. Okay, go ahead and add the same now. This time around, you add it. So add 0.005 to this guy here. So that is 2.474, then plus 0.0005. So that gives me what? 2.4745. 2.4745. 2.4745. Let me check my calculator again. 4745. So that's that. So for this one here too, you do the same thing now. If you look at this now, if you look at after the decimal now, you have what? 4 digits. So the implication is that the place value here will be, this one will go to 0, 0 point, then this last one we go to 1. So 1 2 3, so 3 zeros, 0 0 0, then 1 here. So because this is 10,000, 10,000 th 10,000, so divide by 2. So therefore the error there will now be 0 0.4 zeros before you have 5. So guys, I will not be careful to waste my time with this one. So what you just do now is do 1.45280 minus this to get the answer here, then plus this to get the answer here. This one says to the nearest 0.1 kilometer, so the error will be 0.1 over 2. So that will be 0.05. So now what you have to do now, 20 computers, guy. Okay, let me just solve this. Don't let me waste time. Let me solve this now. Okay, so this is the error here now. So my lower bound now will be 12.6 plus that. So 12.6 plus 0.05. Lower bound. Oh, well, they are actually okay. Let me just get that. No problem about that. So that is 12.65. So my upper bound is 12.65. That's my UP. Then my LP, my lower bound. So I'll just take away now 12.6 minus 12.6 minus 0.05, and that gives me 12.55. So that's the solution to this. They just asked me for the lower bound, and that's it. So this lower bound is it here, lower bound, no problem about that. Now they say calculate difference between the upper and the lower boundary of it. So just take away 12.65 minus this, and I think that will be 0.2. Huh? What am I doing, guy? 12.6 plus 0.05. Why did I write this here? 12.6 minus 0.05. 12.55. I don't know why I did that, guys. Okay, 12.55 anyway. 12.55. So that's when you do calculate the okay, that's that. So just do 12.6 minus 0.05. You have that, and you have this. So calculate the difference. So just take away 12.65 minus 12.55, then that will give you the difference. Hope I'm not to make any mistake, guy. Hope this is 0.05, huh? So I don't like to make a mistake. This is tutorial divided by 2. 0.05 is correct. So plus 12.6, and that is 12.65, and 0.05, sorry, 12.6 minus 0.05, and that is 55. So 12.65 minus answer, so that is 0.1. So the difference is 0.1, guys. At this point I will just guys, I will leave you to, guys, I'm almost through. Let me just I completed all the question already because I've seen the last question. So this one I can discuss. Jafar has a piece of wood that has the length of this, correct to the nearest centimeter, so the error there is 0.5. You know what I'm doing already. So write down the minimum. The minimum will be 29.5. Just take away. Fatima has a piece of wood, correct to the nearest millimeter. Now the problem you guys are going to have here is that this is centimeter, and this asks you to the nearest millimeter. So you ask yourself how many millimeter makes centimeter. So 10 millimeter make 1 centimeter. So since 10 millimeter makes centimeters, and if you are moving from millimeter to centimeter, that is 0.1. So mean that the place value here, because this one, this nearest millimeter is same thing as 0.1 centimeter. And since I'm working with centimeter here, guys, because they want my answer to be write down the minimum of the wood that it must lie. So if you want your answer in centimeter, then this is what you should do then. So nearest millimeter is supposed to be 1 over 2, which is 0.5. That is if you are working with millimeter. But I want to take away from centimeter here. So you have to make your error to be in centimeter. So your error is now 0.1. So 0.1 divided by 2. So that will now be 0.05. So we can now go ahead and do the minimum. So take away and add. So take away It's from, let me just do it, guys, because I'm doing everything already. 18.4 minus 0.05. So, and that will give me 18.35. So this will be 18.35. 18.35. Definitely I've seen that this will be 18.45. Just go ahead and try it. So add it. So that's correct. Jar this one, weigh this one. So nearest 5 kilogram here. Nearest 5 kilogram here, your error will be 2.5. Provided that's what we want to do, but that's not what we want to do. So guys, please don't forget, just like to this site here, guys, you have access to all these questions and you can complete. So let me just go through the last question. So this last question says that 4 shelf units are to be fitted along a library. So the wall is 9 centimeters, so everything 9 centimeter, or measurement to the nearest centimeter. Now, so just like based on my explanation before, and this information here is in meter, but they want us to work to the nearest centimeter. So you ask yourself, how many centimeter make meter? That is 100. So 100 centimeter make meter. Okay, so now if you want to take, but we are working in meter, it means that you are dividing. So that is 1 over 100. So you are working with 0.001. Am I correct? What is 1 divided by 100? Because that will be hundredths. 1 divided by 100. 0.01. So guys, don't forget, because I'm moving from smaller unit to big unit. So when you are moving from smaller unit to big unit, that will be divide. So instead of, because you know that 100 centimeter equals to 1 meter. So the implication is that if you want to get centimeter here, so 100 centimeter make, so if you want this one to be in centimeter, so 1 centimeter will now be 1 over 100. So 0.01 meter. So, and this is the place value now. The place value is 0.01. So now the place value of about 2 will give me the error. So the error is 0.005. So that's what we are going to be adding and be taking away. So now, since I'm working in centimeter now, because my error is now in centimeter, so the first thing I have to do here is I convert everything to centimeter. So this one here will be 194 centimeter. This one here will be 200 plus 6, 206 centimeter. So this one here will be 205 centimeter. Now guys, everything we have here is 900. So just do 900 minus the sum of these 3 guys there, and that will give us this remaining question mark. So let me just go ahead and sum that. 194 plus 206 plus 205, that gives me 605. So 900 minus 605 minus answer, so 295. So the remaining part here is 295. So now everything here now is in centimeters, so that's a good one. So what is the maximum length of the 4 stuff? So what's the maximum length of the fourth? Oh, of the fourth shelf, thank God. So well, my time is fast, man. So of the fourth shelf, just need for this 295, and it's in centimeters, so just take away and add. So our answer here will just be 295 plus or minus 0.005. So the minimum here will now be 295 minus that. 295 minus 0.005. So that will give me the lower bound. So why they give me centimeter meter? Well, they asked me for the maximum. I don't know why I'm just playing. Maximum, just do the addition. 295. So I don't need to do the range. 295 plus 0.005. So that's that. So that's it. So that is 295.005. No, okay, so that's it. So 295 point, okay, cats is in centimeter anyway. 295, okay, oh, point, what? Why am I like this? Okay, so in meter, and I don't need to waste my time. This is 295. So 2 2 meter and 0.95. So I can do 0.95. Then you can now add your 0.005 to add. Guys, this is not funny. So that's 955. So this is 5 now. So your answer will be 2 meter 955 centimeter. Guys, that is the end of our tutorial. Hope you enjoy the show for today, and don't forget to get your resource here, and do have a great day ahead. Bye guys. And don't forget, please like my channel and do well to subscribe to my channel too. Please do well to subscribe to my channel and like. Bye guys. Take good care.